All right, so this is the review for the kinetics exam that we'll take next class period. So a couple of things. I'm going to go over more specifics. I have it in a Word document that I'll post to Google Classroom with this video. But the first things first, I refer to this packet here as our exercises. So exercise packet looks like this. And then I refer to problems, homework problems that I used to give out. These are considered the problems here. All right. So I'm going to share my screen here and we're going to start talking about some of these things here. All right, so with the screen that I have here, if I go full size here, you have to, this is going to be 3 different questions. You have to be able to know, okay, based on the graph, what is my order of reaction? Now, this picture didn't turn out very good. A first order is going to have a straight line graph. If we look at this, it's going to have natural log of the concentration, generic substance A, versus time, and it's going to be a negative slope, okay? Straight line, that's first order. Second order, you have 1 over the concentration of A versus time. This has a positive straight line slope that would look like that. That is second order. And then 0 order, we don't see it very often here, is going to be just the concentration versus time. And it has a negative slope. Okay, so the key thing is what's on my y-axis. First order, straight line. First order, straight line, natural log of that substance. Second order, 1 over that substance. Okay. Those are going to be 3 different questions. I'm going to say, what would a graph look like to indicate a first order reaction? Natural log versus time. What is a second order? 1 over the concentration versus time. And then a 0 order would be concentration versus time. Okay. Now, this is a lot clearer once I post the actual document. And you'll see this. Each of these graphs correspond to the correct spot. All right. So any questions? Anybody need that? All right. So moving on to our next item up for business. Rate loss. You got to know ins and outs of rate loss. This right here could be 3 or 4 questions pretty easily. You need to know, number 1, you have to write rate laws in a specific format. Rate equals K. Okay. Bracket raised to the power. And I could have something like this and I could say, okay, tell me what NO3, what the reactant order is. And you'd say it's second because of the 2. Overall, remember you add your subscripts. So if this was the rate law, you would be given our 2 plus 1 from our rate law to give an overall reaction order of 3. Good example, 4A on our problems. Again, the problems is what I used to give out as homework. So if you're given data on concentration and time, average rate law, that's the very first problem on the problem set there. Pretty good problem there. And then, okay, if you are given a problem, know the difference between a intermediate and a catalyst, okay? Does anyone want me to show you the difference between an intermediate and catalyst?
Sure.
All right, I'm going to use generic letters and symbols here, okay? Let's say here we have in a reaction mechanism, so a proposal, we have A plus B gives us C and D. That's step 1. Then we have, again, C plus E gives us A and F. All right, just random letters. An intermediate is produced in one step and then consumed in another. So C, it's produced as a product in step 1. Then it is used up as a reactant in step 2. Okay, so C right here in my example would be an intermediate. Okay, wouldn't show up in the overall reaction as well. And then a catalyst is used in the very first step and then spit out or shown as a product. So our example here would be this. A is used as a reactant first, and then in the very last step, it is showing up as a product. So what I just put in pink here, that is what we call a catalyst. And know that a catalyst speeds up a chemical reaction by lowering the activation energy. Okay? Questions on that? All right. So keep going through here. Know the difference between an intermediate and a catalyst. Oh, we just did that. Know what happens to the rate of the reaction when the temperature is increased. Temperature goes up. Anybody take a guess what happens to the rate? Rate goes up, temperature goes up, or temperature goes up, rate goes up. Okay. Half-life. This is really important. We went over these in notes and we kind of skimmed through it. First order, half-life is going to remain constant. That's really important, probably very important there. Half-life of a second order reaction, it's going to depend on how much stuff we have initial. Less stuff, slower, more stuff, faster. And then of a zero order reaction, it's going to actually get faster as we progress through the reaction. Finding the rate law and rate constant given lab data. That's key. That's going to be 2, if not 3, of the fill in the blank. And so really good examples are both of these. This is that day 2 worth of notes where we looked at lab data and we said, all right, we need to hold one thing constant, double or triple the concentration, see what happens to the rate, and then hold the other thing constant and see what happens as we double or triple that second thing there. That's a really good problem to do. Number 5 on each of those sheets, the problems and the exercises. Then given the reaction order. So I may say, hey, this is second order overall. Go through and utilize the integrated rate law. Okay. Good example, problem number 8. Reaction diagram. Know that your activation energy is that hill, that hump there. Your delta E is your change of energy. So from reactants to products, that's where that delta E is. Know the definition of a catalyst. And then if you are given a rate, know how to convert the rate to any other substance. Right here, that last little bullet, we use stoichiometry. Okay. Questions? Multiple choice, very little math. Like 1 or 2 questions. Fill in the blank has all the math.
Okay.
Adios.